So I'm Dustin. The research that I'm showing is Google Earth Engine and the use of open big data for environmental and climate change assessments. I'm using Kosovo as a case study. I am a Fulbright research fellow with the University of Pristina. And I am a PhD student at Texas State University. So what I was trying to do, what I did basically was I took openly available models. I re-engineered them for Kosovo using Google Earth Engine and tried to understand tried to put pieces together on how to build a bigger tool that can be used for data scarce or resource scarce environments, which Kosovo is. I targeted very specifically the issues that Kosovo is having, the environmental and climatic issues that they're having, and trying to provide a method that gives a better understanding of the issues. So the models that I used here were air pollution and looking at population exposure. I took auxiliary information from other publications that talked about what the exposures are, where they're coming from, to understand what these exposures are likely causing or what the impacts of these exposures are. Looking at deforestation using urban extent and using GRACE modeling for detecting anomalies within the Lignite Basin, which is the basin that we're in right now, which is the karst aquifer that is the only water source for Kosovo. So, briefly on Kosovo, there's a lot of environmental issues within Kosovo. It is also very poor. Most of the people here rely on diaspora money and grants. There's no capacity. There's even less capacity to do things like climate change resilience, to do environmental assessments. Most people are just trying to survive. And there's a very little capacity to gauge any form of the scale of the issues that are occurring. So Kosovo is still in a frozen conflict, which some of you are probably aware of. And it's basically the struggle of a hostage state economy and trying to figure out how to use resources and target issues using open resources. There's also issues like systemic and systematic corruption that make this region very vulnerable to climate change and global warming, climate change and global warming. So first, the air pollution modeling. We assess the spatial distribution and probable health impacts for NO2. So NO2 is a byproduct largely of combustion. In this case, the largest form would be that, which is Kosovo A power plant, which is a lignite coal power plant located just outside of Pristina. The populations are subbed for 28 municipal subregions, and that is the equation for population exposure that was used. Now we're using GRACE. So the technique uses 2 satellites to measure. It's basically just measuring the gravitational from the moon to understand water changes. We're targeting the Lignite, like I said, because it is the only karst aquifer in Kosovo. It's the only water source in Kosovo. And that is the equation to understand how that detects that anomaly. The urban extent. We used Landsat 7 data for this. The model itself was not functional in the way that I wanted it to be. It used an unsupervised classification, and there were just a lot of issues with it. I wanted to do something else, but it didn't work. The deforestation model. So I did do 2 deforestation models for this project, but one of them proved to be less useful. It was trying to detect active deforestation, and it was not working. Even though I knew regions where deforestation was currently actively occurring in Kosovo, it did not adequately detect it. So the model that was built was not functioning the way as anticipated. This other one did work really well. It's using a spectral mixing and contextual classification algorithm. It determined, so the model itself was designed to determine no change, logging, deforestation, and regrowth. What I found was that even with regrowth, it was detecting different types of things, which we'll talk about later. And it, at least in theory, for the accuracy assessment, it was high. It did have high accuracy from the model itself. So, results for air pollution. The big red spot in the middle, that's the coal power plant. The surrounding regions obviously have large impacts, or having drastic impacts from this, health impacts, large health impacts. Parts of the reason is because that coal contains heavy metals. It contains a lot of things that you don't want to breathe, and it is being used like that. So the left side, I think it's left for you too. Yeah, left side shows winter. If you're ever in Pristina in the winter, you'll know what I'm talking about. The right side is summer. It's a lot easier to breathe, less human impact on it. It's more, obviously it's going to go higher into the atmosphere. So lignite, specifically the coal that's being burned here, is one of the dirtiest coals. Contains arsenic, chromium, nickel, and mercury. All derived from the type. NO2 concentrations we're basically, in theory, we're using these as a proxy for the combustion product. So we know what that combustion product is. Therefore, we can assume the health impacts that are going to come from the exposure modeling. And along with other pollutants that are commonly found with NO2. Some of the other things that you see within the NO2 modeling here, or within this model, you see bricks, you see transportation and other industrial activities. It's important to mention that Kosovo does not monitor many pollutants, almost any, and it doesn't meet its goals for a lot of the things it is supposed to be monitoring. And a lot of things are not accounted for in risk assessments. So the urban extent, this model didn't work mainly because there was a significant amount of errors and sensor artifacts. So it looks good from here, but if you look at it on the picture, it does not look good. This is relatively what Kosovo does look like, where the urban areas are. But there was a significant amount of data corruption, and I wanted to do an urban extent change to understand how Kosovo has changed from 2000, from the war, and it just ended up being incorrect. This is basically the clearest window I could get from that model that was built. This is the deforestation model, showing where forests, where these things are occurring. Deforestation is the most committed crime in Kosovo. And illegal deforestation is a racket. So, looking at it by region, you can see the differences and changes. Some of the regions where it's most prevalent are going to be around major cities, because it's connected with energy prices. The more energy prices rise, the more deforestation rises. So it's typically in regions where that is going to be impacted. One of the interesting things that did show up on this model was the upslope migration that was occurring due to climate change. So within the Rugova and Shaw Mountains, which was here, it detected regrowth in regions where nobody was going or nobody could get to. And in theory, what it's detecting is the regrowth of growth of trees, new trees that are coming in due to the reduction of the ice pack, which is also impacted by the coal power plant, which is depositing pollution on it that is then increasing its capacity to absorb heat. So there's extensive deforestation within the pine in the Rugova Mountains, and detection of major deforestation in Jalan, which I believe is feeding Pristina during the winters. So for the water anomaly detection, this is an interesting outcome, which is that at least over the period of time that the model ran, There's increasing anomalies, which means that there's water security in the region, or at least underneath, but I think that has to do with snow melt and water anomalies, more water anomalies. This is from a different project, but it's looking at Man-Kendall for water balance, the trend analysis on water balance, and there's decreasing water balance within the basin itself, which I think that has to do is impacting its absorption capacity for the region and increasing its ability to store. So the paper we're looking to highlight the importance of access to open resources and geographic data for developing countries, specifically taking models, taking this giant pool of data and figuring out how to generate insights that are usable, that are utilizable, that have value for developing countries. To address sustainability and climate change challenges that are going to continue to get worse. I feel like it demonstrates the value of an open, of a free and open tool that can be used by municipalities with the specific intent of drawing different insights from models that allows developing countries to have easy access to data insights that can be used to adapt. It's a very easy way to take a large data set and bridge a gap that is growing further and further within climate change resilience and climate change capacity, climate change adaptation capacity. The complexity, connectivity between environment and climatic changes, it's considerable challenges in data interpretation and analysis, and there's a strong need for applied methods, for methodologies, models, and use of these data sets to do that. I think there's an immense untapped potential within remote sensing and big data in Google Earth Engine or open source attachments to Google Earth that allow for model detection that can be used to provide developing economies and developing countries with insights within that big data set that is fairly hard to access for somebody with no resources. Final conclusions: Kosovo faces a lot environmental issues, degradation, poverty, limited capacity to conducting these assessments, limited capacities with institutional frameworks. It's missing institutional frameworks that can drive an understanding of this. So, using these styles of models and creating more applicable versions of these models that are more ready to be handed to these developing countries provides environmental sustainability and resilience building for them. And it's an immense opportunity to build new technologies that can serve countries and places that have less resources and less capacity. Questions?